Hello to all my viewers. This is Dr. Dhaval Maheta, and today I will explain how to plot the lift chart in support vector machine in KNIME. Support vector machine is a powerful and widely used machine learning algorithm that is used for both classification and regression problems. Support vector machine is a discriminative algorithm that separates the data points into different classes by constructing a hyperplane or a set of hyperplanes in high dimensional space. Support vector machine works by finding the optimal hyperplane that maximizes the margin between the two classes, with the margin being the distance between the hyperplane and the closest data points from each class. I've already explained the theory in my previous video, that what is a hyperplane, what is support vector, and what is a margin. Kindly refer my previous videos. We have also discussed the confusion matrix on the basis of which we assess the classification accuracy of the model. Now let's talk about the lift chart. A lift chart, also known as a gain chart, is a visualization tool used to evaluate the performance of the binary classification models such as descent tree, logistic regression, naive Bayes, and support vector machine. The chart compares the predicted probability of the positive class against the actual proportion of the positive instances in the dataset. Lift measures how our model is performing in prediction against the prediction without the model. You can see here the table has been given. If we are having 10,000 cases, they are divided into 10 parts. 10 parts, that is 100% probability divided into 10. So for each part, the probability is 10%. Now in the first part, out of 1000 cases, 876 in 876 cases, the event happened. So the cumulative response is 876. In second part, 743 happened. So 743. So 876 plus 743, 1619. Right? So what we get is 22.70 percentage, that is 876 divided by 385,859. This is 19.25, which is 743 divided by 3859. The cumulative gain is 22.7 percentage plus 19.25, which is 41.95. In the first part, out of 1000 observations, the number of events that occur are 877, which is 22.7 percentage. The gain for the first part is 22.7 percentage. In the second part, out of 1000 observations, number of events that occur are 743, which is 19.25% of the total event, 3859. The gain for the second part is this plus this. The cumulative lift is, for the first part, 22.7 percentage divided by 10, because we are dividing, it's a first part. So it is 2.27. For the second part, it is 41.95 percentage divided by 20, because we are considering two parts. So it is 2.098. Now how we can plot the lift chart, let's see in the KNIME. So I'll activate the input output from here. I'll double click on it to browse the data set. Now I'll browse the data set, which is in CSV format. D-drive, this is methodology, predictive analytics, KNIME, data, part 1, open, click OK. Right click on it and execute. Right click on it and you can see the file table. I'll request all my viewers to kindly refer the previous videos of support vector machine to understand the concepts. Now I'll activate the column filter so that I can select only those variables which are necessary to create the model. Age, resting blood pressure, cholesterol, maximum hours of exercise, and heart disease. Click OK. Right click on it and execute. Again, right click on it and see the filtered table. Now, again, activate the partitioning of the data set, in which the data will be divided into 80% training data set and 20% testing data set. Stratified sampling, click OK. Right click on it and execute. Again, right click on it and you can see the first partition, which will be used for training purpose. And this is the second partition, which will be used for testing purpose. Activate the SVM learner from here. Right click, configure, make sure heart disease is our target variable, click OK. Right click on it and execute. Take some time. Now right click on it and you can see the SVM view. SVM does not generate any equation, just like regression or logistic regression analysis. So you'll have to activate the predictor. The predictor will get its learning from this node, but we will feed the data. The testing data set will be fed from this partition. Right click on it and configure. Please tick mark on both these boxes where we want to do the prediction, where we want to create the column name with the prediction heart disease with its probabilities. Right click on it and execute. Again, right click on it and see the classification. So this is a prediction which has been done according to the algorithm, and this is the real data. Now you can see for this cases, the algorithm has worked perfectly. No, no. Here also, no, no. But if we talk about this, a person does not have a heart disease, but the algorithm predicted yes. So there is a misclassification. Similarly, it can happen reverse also, that here it is, yeah, yeah, this case. A person does not have a heart disease, but a person has a heart disease, but the algorithm predicted no. This is also misclassification. So proper classification is no, no, and yes, yes. These are correctly classified cases. Now, on the basis of this, the score will be generated. Scorer. Right click on it, configure, activate the heart disease from here. Click OK. Right click on it and execute. Again, right click on it and you can see the confusion matrix. I already explained the confusion matrix in my previous video. Kindly refer it. Now we want to activate the lift chart. Right click on it, configure, heart disease, prediction, probability column. Yes, puzzle list. Yes, click OK. There is a cross. Again, go and configure general plot options, create image and plot. Click OK. Right click on it and execute. Again, right click on it and see the image. Now you can see here for first 10% of the cases, the lift is 1.7, which is considered to be quite good. And for next 20%, the lift turns out to be the red one is 1.1. Again, it is 1.41. But after 60 or 70% cases, lift drastically drops down. You can also create the cumulative gain chart. Right click on it, configure, show the cumulative gain. Click OK. Right click on it and execute. Again, right click on it and click on the image. So there is a cumulative gain which you can see here. So this is how you can generate the lift chart in KNIME. For more videos on KNIME, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I have already uploaded many videos on KNIME.